Hello everyone, this is our second class of quantitative techniques. In the previous class, we have studied about the uh, operation research and the quantitative techniques, that what are the history of the quantitative techniques, what were the definitions about the quantitative techniques. Now in this class, we will study the different type of techniques starting with the LPP. So the topics which we have to cover here are the LPP, that is a linear programming problem. We will study about the characteristics of an LPP. We will study about the applications of an LPP and the mathematical formulation of an LPP. So before starting the linear programming problem, I would like to explain that what is the literal meaning of this linear programming and the problem. LPP is a linear programming problem. So the linear means that whatever the functions are there, whatever the equations will be there, that should be in the linear form. This linear word you people have heard about in the your class 7th, 8th standard, where we have to prepare the linear equations. The linear means that the variables, whatever the variables we will use here, should be in the linear function. It should be in the single power. So any variable, if it is in a single power, and it is making any equation or the function, that is known as a linear function or the linear equation. For example, x plus y is equal to 4 is a linear equation. Now when we talk about the programming, it's programming doesn't mean here that we have to open the programming language and we have to do the coding. This programming is basically the process or the set of rules are there which we have to follow to solve any kind of a situation or any kind of a problem. And the last part is the problem, which you all know that what is the issue. So linear programming problem is any set of rules consisting with the linear function or the linear equations which are to be solved. Now the linear programming problem provides a method to optimize operations with certain constraints. That means what? We have to optimize the thing. And there we have the different type of constraints that we have to see. It is used to make the processes more efficient and cost effective. As we discussed in the last class, that whatever we are doing, that should be the optimization technique. And when we are doing the optimization means to make the decision better. So when we are making the decision better, that the decision will be the most efficient and it should be the effective. Some areas of the application of linear programming includes food, agriculture, engineering, transportation, manufacturing, energy, and apart from that we have management. In the management we have marketing and the different part of this management. Linear programming problem in mathematics is a system process of finding a maximum or minimum value of the variable in a function. As we discussed, that the optimization, and optimization means the either to maximize or to minimize the function. So we have to find out the maximum or the minimum value of a function. It is also known by the name of optimization problem, as we have discussed. LPP is helpful in developing and solving a decision making problems, mathematical techniques. Now these are the following characteristics of an LPP. The first one is the decision variables. Decision variable is basically that whatever you have to produce, whatever you have to take the units on which you have to make decision. The simple meaning that those variables are which on which you have to make the decisions. So like for example, if we are in the manufacturing industry, then if we are getting the product profit on the units, so we have to decide that how many units have to be produced. So the number of units of a particular product is a decision variable. If we talk about the finance part, then where we have to invest the money, then if I have to invest the money in real estate, if I have to invest the money in stock market, then I have to decide that how much amount has to be invested. So the amount is my decision variable. Similarly, when we talk about the marketing research, where we have to do the research, and we want that the advertisement should reach to the maximum people. So how many advertisements should be given in the different media is again your decision variables. So the decision variables are those on which you have to make the decisions. This is a very important and the first point of the characteristics. Then the second point comes as an objective function. In the objective function, since we are studying the linear programming problem, so the objective function should be in the linear form. And when we are talking about the objective function, this objective is, as a nomenclature is there, the objective. What is the objective of your problem? What is the objective of your situation? What is the objective of your issue? Either it has to be maximized or it has to be minimized. Means if the situation says that we have to optimize the results, so we have to find that is he talking about the profit or is he talking about the cost. If he is talking about the profit, that means we have to maximize it. If he is talking about the sales, that means we have to maximize the sale. If he is talking about the revenue, that means we have to increase or we have to optimize or we have to maximize the revenue. Similarly, if he is talking about the cost, loss, time, distance, that means we have to minimize. So optimization means that either we have to minimize it or we have to maximize it. When we write down this objective function, the form will be either max z or min z. Why we are using this z? We are not using maximum p for the profit. We are not using max s for the sales. We are not using minimum cost, minimum c. Why? Because for the different type of problem, we have to use a different nomenclature. So it is z is a generalization statement. So whatever we have to use, we will just write down in the statement and then we will use the notation as a z. Now we have constraints. Constraints are basically the limitations. Limitations of the resources. Limitations are for the resources. That means whatever the resources we have, it's not that we have the unlimited resources of each and everything. If I have the budget, that means the budget should be limited. Budget cannot be unlimited. If we have the machines to be used, the machine cannot be used 24 by 7. We have to give the rest to the machines. If we are talking about the human power, also the man cannot be used or the machine or the human power cannot be used 24 by 7. The companies work 24 by 7, but they work in shifts. So every shift is of 8 hours, 9 hours, it depends. So we have the limitation on the working hours, we have the limitations of the machine hours, we have the limitations of the budget. If I have to invest the money in some of the portfolios, it's not that I can invest unlimited money in that. There is a limit. So everywhere there is a limitations is there. So that is known as a constraint for us. So the constraint may be either of a maximum type or the minimum type. So if we have either, we will use in the constraint the less than equal to sign or the greater than equal to sign, but also in some of the cases we will use the equation sign. The last part of the characteristics is non-negativity restriction. That is a most important one which is not to be ignored. The non-negativity means the thing which is not negative. It may be zero. Otherwise, if the people will say that non-negative means which is positive. No, non-negative means which is not negative. It may be zero. So the non-negative restriction means what? Whatever the decision variables we are using, those decision variables cannot be negative. Because if I am talking about the number of units to be produced, you cannot produce negative units of the product. If I am saying that the amount has to be invested in some of the portfolios, you cannot invest zero, you cannot invest negative amount in the portfolio. If I have to give the advertisement in any of the newspaper or any of the media, you cannot give the negative number of advertisements in any of the media. So the variable can be zero but cannot be negative. Now the applications of an LPP are, the application of an LPP is very wide. It can be used in any of the industries, the sum of the marketing research, finance, operations, diet problem, transportation, HR. When we talk about the marketing research, I told you that in the advertisement, what we have to do, we have to give the advertisement in the different media. So we have to decide how to give the advertisement in the different media so it can be reached to the maximum people. When we are talking about the finance, the wealth management, in the wealth management we have to give the idea to the other people that how they can invest their money in the different portfolio to get the maximum return. When we talk about the operation, that the operation people can manufacture each and everything, but in some of the cases when they have to produce the thing or they can outsource it, that would be cheaper, so they have to decide how many units to be produced or how many units to be buy. Similarly, in the diet problem, the these days it's a in a fashion that the diet is there. So diet, in the diet, what the vitamin A should be there, what content of the vitamin B should be there, what content of the vitamin C should be there. So each and every diet, there should be that the minimum amount of vitamin A is there, the maximum amount of the vitamin C is there, so that has to be decided. Similarly, in the transportation problem, when we have to transport the units from one place to another place, then we have to decide that how these units can be transported. Again, this can be converted into an LPP and then can be solved. Similarly, in the HR problem, when we have to assign the different jobs to the different people, so we have to decide how to assign the jobs so that my either it is a sales or it is a profit, so it is maximum. Now we come over the formulation of an LPP. Formulation means that the conversion of a problem into a mathematical form. That means whatever is the issue, that we have to convert into a mathematical form so that we can solve it with the methods of solving the LPP. To formulate any problem into an LPP or into a mathematical form, we have to first identify the decision variables, as there are the four type of characteristics that we have to follow here. That means first of all we have to identify the decision variables, that what are the decision variables to solve the problem. The second is we have to identify the objective. Objective means that it is to be maximized or to minimize, and accordingly we have to construct the objective function. That means either the max z or the min z. The third one is the identify the limitation and the prepare the constraint. We have to identify that where we have the constraints, on what basis we are having the issues, so we have to produce or we have to prepare the constraints. And the last one is we have to mention the non-negativity restrictions of the issues. Now this is one of the example of manufacturing industries, where a company is there who is manufacturing the two types of products using the three machines M1, M2 and M3. Every machine can produce both the type of product but on a different efficiency. So machine M1 takes 15 minutes to produce one unit of a type X product, and the 18 minutes to produce one unit of type B product or the type Y product. Similarly, M2 machine take 20 minutes for X, one unit of X, and 15 minutes to produce one unit of Y. Similarly, machine M3 takes 12 minutes to produce one unit of type X product and 20 minutes to produce type one per unit of type Y product. These machine M1, M2 and M3 are available for 20 hours, 15 hours and 18 hours respectively in a day. Now from here we can see that the machines which are available to us in a day are 20 hours, 15 hours and 18 hours. Now these timings cannot be the minimum timing. These timings should be the maximum timing. If I'm saying that the machine is available for the minimum 20 hours, it means it can be available for the whole day. But if you use any machine for the whole day, it will be uh, it will not work properly. So these timings of the machines are the maximum time. These are the hidden word, it's not written over here. So what we have to see that the timings, that is, we have the constraints on the number of hours of a machines to be used. Now the company makes a profit of one unit of type X product rupees 10 and the one unit of type Y product of rupees 15. Formulate the problem as an LPP to maximize the profit. Now from this last line of the uh, PPT of this question, we can see that the objective is to maximize the profit. So what we have to do? We have to maximize our profit. Now the solution of the given problem is, first of all we have to identify the decision variables. Since this is a manufacturing problem, so we have to identify the number of units to be produced. Let X be the number of units of a type X product and Y be the number of units of the type B product to be produced. Now the objective function is, since the company has to maximize the profit, therefore how to define this function? So there is an statement Since the profit on 1 unit of type X product is rupees 10, therefore the profit on X units of the type X product will be rupees 10x. Similarly, for the Y, it will be 15y. Now, if this is the profit, so we have to add as a total profit. So the total profit is 10x plus 15y. Now this function has to be maximized. Therefore, the objective function is max z is equal to 10x plus 15y. Now we are talking about the constraints. Now the constraints are the number of hours of a machines to be used. So we have the three machines, so the machine M1, M2 and M3, and we have the limitation on the machine hours to be used. Now machine 1 taking 15 minutes to produce 1 unit of a type X product, therefore it will take 15x minutes to produce X unit of the type X product. Similarly, machine M1 will take 18y minutes to produce Y units of the Y product. So total time of machine X would be, machine M1 will be 15x plus 18y. Now machine M1 is available for 20 hours, 20 is the maximum hours, and the above timings were given in the minutes. This time is given the 20 hours, so we have to convert the 20 hours into the minutes. So 20 hours is equal to 20 into 60 is equal to 1200 minutes. So the constant for the M1 is 15x plus 18y less than equal to 1200. Similarly, you can find out the constant for the M2. So M2 is taking the 20 minutes to produce 1 unit of type X product, so it will take 20x minutes and the 15y minutes, and it is available for the 15 hours. So this is 15 into 60, that is a 900. So less than equal to, since this is a maximum time, it cannot be more than 900. So less than equal to, that means we can use 900 hours or the less than 900 hours. Similarly, for the machine M3, 12x plus 18y less than equal to 1080. That is 18 into 60. Now these are the constraints for the machine M1, M2 and M3. Now the last part is the non-negative restriction. Since we are manufacturing the product, therefore the number of units cannot be negative. Therefore X comma Y greater than equal to 0. It should be always positive.
We have to find the maximum profit the company can earn with the constraint. The constraint here is the production budget. But how do we approach this problem now? First, let's try to represent this problem in a tabular form. Can you give it a try? Here it is. Go through it well. Note that we have to convert this problem into a linear programming problem. And how do we do that? By writing the given problem in the form of mathematical expressions. Like in this case, the company wants to sell some number of products A and B. As we don't know the exact quantity, let's assume the number of units of product A to be X and the number of units of product B to be Y. Now, can you tell me the total cost to manufacture these many units of A and B respectively? Yes, it will be 200 times X and 150 times Y. We're just multiplying the quantity with the price. Next, let's look at the constraint. It says the production budget is $50,000. That means the cost to be incurred should not exceed $50,000. It can be less than or equal to $50,000. Can you write this constraint in the form of a mathematical expression? Here's the answer. This expression represents the budget constraint of the problem. The total cost should not be more than $50,000. Now let's express the total demand of the two products in a similar manner. Give it a try. The combined monthly demand of the two products will not exceed 500 units. Therefore, we use the less than or equal to sign to write this expression. And which constraint does this expression represent? Yes, it represents the demand constraint of the given problem. This means if the company produces more than 500 units of products A and B in all, it might not be able to sell them. Are there any other constraints in the problem? Not really. So let's look at the profit element of the two products. Can you tell me the objective of the company in this case? The company would like to sell its products A and B in such a mix that it yields maximum profit in a month. In simple words, the company would try to maximize the profit which it can yield by selling A and B. Now let Z denote the total profit for the month. Can you write the total profit in the form of mathematical expression? The total profit Z can be written as this. It's the product of the quantity and the profit per unit. With this, we will write the objective function of this problem. The objective function in a linear programming problem is a mathematical expression of the ultimate goal. So, we have the two constraints here, a budget constraint and a demand constraint. This is how the whole problem looks in terms of mathematical expressions. This is the objective function, and these are the two constraints. There's just one thing we need to know here, and for that, I want you to answer a question. Can the number of units produced by a company be negative? You're right, it can never be negative. So we need to add the non-negative constraints. It can be written mathematically like this. It's very important to write the non-negative constraints in the formulation of a linear programming problem. Did you notice what we did? The entire problem of so many words is reduced to the simple format using mathematical language. As the problem is formulated in the linear form, it's called as linear programming.
So as a summary of this class is what we have studied about the LPP, that what is LPP basically, what are the characteristics of the LPP, what are the applications, and what is the how to formulate any problem into an LPP or into a mathematical form so that we can solve it. Now when we started this class, so there are some questions in the mind, and when we end this class there will be also some questions in the mind. In the starting, that the questions were that what is an LPP and how to solve it, what is the applications. So these are the questions which can be uh, you asked, or which can be thought, that what is an LPP, why we are solving the LPP, what is the application. And the last part is, now we have formulated, so we have a mathematical form, how to solve it. So how to solve the problem will be discussed later in the next class. And now the same thing, that we have the references, you can refer any of the book which is over here. Thank you so much.